The purpose of this video is to help you with the analysis of your titration curve. The first thing that we'll need to do is connect the points on your titration curve so that we can analyze the curve that you have in front of you. To do this, you'll go to Options and select Graph Options, and then you'll get this window, and under Graph Options, you will choose to connect the points. There are a few things that you're going to do with this curve, and one of them is going to be to discuss the shape of the curve, and you're going to discuss it in terms of the amount of acid and base in the titration. And you can really focus on discussing what you see in three regions. So this initial region, this steep part of the curve, and then this final flattened region. So for each of those parts of the curve, you're going to want to discuss what is in the container and why there is such a trend of change in pH. The other thing that you're going to be doing is using the information from the curve to find the concentration of the hydrochloric acid. Our known solution in this case is the sodium hydroxide. So what we need to do is we need to find the volume of the base that is added to reach the equivalence point. When you look at a titration curve, the equivalence point is not defined as pH of 7. Unfortunately, pH meters need to be really well and carefully calibrated in order to really get a pH of 7 when we're at the equivalence point. And in addition, regular distilled water brings acidity to the solution. So it is possible that even though when we're at the equivalence point, it is possible that the pH is slightly below 7. So we need another means in order to find that value. And we're going to use a graphical mean. So in the previous parts of the experiment, used an indicator to identify the endpoint of the titration, which was helping you to predict the equivalence point. And in this case, we're going to find the equivalence point on the graph. In any titration curve, the equivalence point, or the point where the moles of acid is equal to the moles of base, is the midpoint of the steep part of the curve. Now this, just looking at the graph, would be quite difficult to find. So we're actually going to use calculus in order to help us. And fear not, you don't need to actually understand calculus, but this is a good little small introduction into what you will learn in calculus. This curve, as you can see, is increasing, and then at the midpoint, it actually changes to a decreasing curve. And when you have a curve that changes from increasing to decreasing, we call that an inflection point. So what we need to be able to do is find the exact point on this steep part of the curve where there is an inflection point. And we find that by using what are called derivatives. Derivatives you'll learn in calculus are finding the slope of the tangent at particular points in a graph. But for our purposes, we need to know two things. One, when you have a first derivative, the inflection point is going to reach a maximum. Two, when you have an inflection point, the second derivative is going to have a value of 0. Now, because of how we've done this, we don't need to worry about the calculus and figuring that out. We actually have the first derivative and second derivative data. So if you go to page 2, you'll see your first derivative data. And what you'll see is that your graph should be flat, and then there's a peak where there's a high point, and then it goes down, and we call this the maximum. So an inflection point is a maximum at the first derivative. Okay. So this is the point that we're actually looking for. So we want to know the volume exactly at this moment where we've reached this peak in our first derivative. Now reading that value off this graph would also be difficult. So we're going to rely on our second derivative. So what you want to do is go to page 3, and what is true about an inflection point, it is that the second derivative has a value of 0. So this point right here is what we're looking for. We want to know the volume where we cross the axis. Now, in order to do that, we're going to zoom in, and we're actually going to find an equation of a line. So to zoom in here, it might take a couple of tries, but what you can do is you can go over here and, somewhere between 10 and maybe 13. So I'm going to choose my data that goes from 10 to 13, and then I'm going to click on zoom, and it's zoomed in here. Still, I could zoom in a little bit further, so maybe it's in and around 12, so maybe 11.5 to 12.5. Okay. So this is good. I can probably, if it allows me here, I'd like to stretch. It's not going to allow me that. I didn't practice stretching the scale, so I apologize, but this is good. This is fine, because what we need to make these 2 points here make a line and cross this axis. So what we want to do is we want to find the equation of the line of these 2 points. And it's around 11.9. So the point at 11.9 and the point at 12, I'm going to highlight those. And what I'm going to do is I'm going to go to Analyze and Linear Fit. Okay, and you'll see it's actually fixed it for me here. And what I've done is I've found the line, okay, between those 2 points. And this is the equation of that line. Okay, and it's got a perfect correlation because it's only 2 points. Now what I want to do is I want to find the point at which the second derivative is equal to 0. So the next thing I'm going to do is go to Analyze, and I'm going to go to Interpolation Calculator. And what I want to do is I want to find where the second derivative is 0, and that will read the volume. So this is the volume, 11.94, and it's pretty precise. 11.94 is probably as precise as we can actually work with. Okay, so I'm going to move this over here. So my volume of my equivalence point is 11.94. Okay, and this is not a point that we actually had on our graph. Okay, if we look back to page 1, okay, 11.94 is the volume when I'm at the midpoint. So it's somewhere in between these 2 points. Okay, and the volume is 11.94, which I wouldn't have been able to read on this one. Okay, so that's the value that you need and the graph. And so you just want to organize these so that you can see them and you can also see your graph. Save your work and you'll be able to print, and you've got all the data that you need.